In lesson 2, when simplifying radical expressions with quotients, we learned a procedure briefly called rationalizing denominators. Let's look at that procedure in more depth in this lesson. So to refresh, rationalizing the denominator is a procedure to find an equivalent expression without a radical in the denominator. In fact, we would say that a radical expression is not simplified until our denominator does not contain any radicals in it. So we must know how to do this procedure. So we can rationalize the denominator in two basic circumstances. One time you may need to rationalize the denominator is when you have one term in the denominator that has a radical, or it could happen where you have two terms in the denominator and one or both of them have radicals. And in this lesson, we're going to look at how to do both of these processes, how to do it with one term and with two terms, and how it varies from one another, because there's a slightly different procedure for each. So let's begin with simplifying something like 2 over the square root of 7. So to rationalize the denominator when it contains one term, remember from an earlier lesson, all you need to do is multiply the numerator and denominator by the radical in the denominator. So for the example, 2 over the square root of 7, to rationalize that denominator, we want to multiply it by some value that's equivalent to 1. So we'll do the square root of 7 over the square root of 7. And when we do this, in the numerator, we multiply across, you get 2 times the square root of 7. And in the denominator, the square root of 7 times the square root of 7 is just 7. So now this is simplified. For our second example, we realize that sometimes when we want to rationalize the denominator, we'll need to simplify the expression first. So this is the square root of y over the square root of 40, which is the same thing as the square root of y over the square root of 4 times the square root of 10, which means it's the same thing as the square root of y over 2 times the square root of 10. And now we see that though this is close to being simplified, we still have the square root of 10 in the denominator. So to simplify this expression, we are now at this point. We rationalize the denominator by multiplying it by the square root of 10 over the square root of 10. And when we do that, we end up with the square root of 10y over 2 times the square root of 10 times the square root of 10 is 10. So 2 times 10 would give us 20. And now our denominator is rationalized. The process is slightly different when we're doing it and it contains two terms. So when it contains two terms, you multiply the numerator and denominator by the conjugate of the denominator. So let's look at what this vocab word conjugate means. An example of conjugates would be 3 plus the square root of 7. The conjugate of that would be 3 minus the square root of 7. Or the square root of 3 minus 6 root 2 and the square root of 3 plus 6 root 2. So you can see these are basically two conjugates are expressions that have the same two terms except an opposite sign in the middle. So if we look at our example 3 over 2 times 2 plus the square root of 5, to rationalize the denominator, we'll have to multiply it by the conjugate. But first, let's see why we need to do that. So let's show you an example of what not to do. If you simply tried to multiply this by the square root of 5 over the square root of 5, like we did when there was only one term, you will not get rid of your radical in the denominator, because this is what would happen. In the numerator, you'd get 3 times the square root of 5, and in the denominator, when you distribute this, you end up with 2 times the square root of 5 plus 5. And so you see you still have your radical expression in the denominator. So that's why it doesn't work to simply multiply it by root 5 over root 5. You need to multiply it by the conjugate. So in this case, what we would multiply it by is 2 minus the square root of 5 and 2 minus the square root of 5. Again, it's still a value equal to 1. but we use the conjugate. So when we multiply this across, we'll have to distribute. In the numerator, we will get 6 minus 3 square root of 5. And in the denominator, when we distribute, we'll have to remember to multiply both of these. 2 times 2 gives us 4, minus 2 root 5, and then plus 2 root 5, and then square root of 5 times the square root of 5 is 5, and that's negative because there's a minus sign. So when we simplify this, it's a bit crowded there, so let's create a little bit more space. We'll end up with 6 minus 3 square root of 5 over, these two terms will cancel out, so you just get 4 minus 5, which is negative 1. And if we'd want to simplify that a bit more, we would divide each of our terms by negative 1, and we'd end up with negative 6 plus 3 square root of 5. Let's do 2 more examples together. Our first example, let's simplify it and then rationalize the denominator. So for our first example, let's begin by remembering what we do with quotients. We should simplify this expression as much as possible. So we'll call this 7t squared, square root of 7t squared, over the square root of 32, because we'll cancel that t with that t. And now let's write this as t square root of 7, because the square root of t squared is t, over the square root of 16 times the square root of 2. And so that becomes t times the square root of 7 over 4 root 2. Now we just have one term in the denominator, so to rationalize this denominator, I multiply it by square root of 2 over the square root of 2. And my final answer will be t times the square root of 14 over, in the denominator, the square root of 2 times the square root of 2 is 2, so 4 times 2 is 8. Now let's look at our second example. In our second example, we'll want to rationalize this denominator, but now I have 2 terms. So to rationalize it, I should multiply it by the conjugate of the denominator, which would be square root of 7 plus square root of x, and the square root of 7 plus the square root of x. Again, don't worry about what the numerator looks like. Your focus is on the denominator. So let's do this multiplication. And remember that we're distributing. 2 times the square root of 7 is 2 square root of 7. Plus 2 square root of x, plus the square root of 21, plus the square root of 3x. And though that looks complicated, we're at least on the right track because now we're going to be able to rationalize the denominator. Let's do that. The square root of 7 times the square root of 7 is 7. Then you get the square root of 7 plus the square root of 7x, and minus the square root of 7x. And then you get minus square root of x times square root of x is negative x. And so when you simplify it and add these 2 terms together, your final answer will be 2 root 7 plus 2 root x plus the square root of 21 plus the square root of 3x over 7 minus x. And so take a look at one final thing here when multiplying by the conjugates. You'll notice that when you multiply by the conjugate, like we did right here, your middle 2 terms will always end up eliminating just like this. So if you remember that, you might be able to do these operations of multiplying by conjugates a little bit quicker.